In this lecture, we're going to talk about caching. I mentioned it in the previous lecture. Just to make sure we're all on the same page, I want to quickly review what caching is. Caching is a concept where copies of data and assets are stored for faster delivery. It sounds like a simple concept, but there's more complexity than you can imagine. There's a famous quote by Phil Carlton that goes like this: "There are only two hard things in computer science: caching and naming things." Caching is meant to increase the performance of an application, but the question is, when and how do we use caching? That's a tricky question to answer because there are various strategies available for implementing caching. Let's imagine we're trying to cache CSS files. Typically, assets like CSS files don't change frequently. We don't need to make a request over the network to retrieve the CSS file. We can request it once and then store it in a cache. Subsequent requests for the CSS file will be served from the cache. This is what's known as a cache first, then network strategy. The browser will search for files in the browser's cache. The browser has an API we can use to store files locally on the user's machine. If the browser can't find a file on the machine, it will request the files from the network. If the server responds with a file, the file will be cached for subsequent requests of the same file. This strategy works incredibly well for static files. It's another story for data from Firebase. It's entirely possible for cached data from Firestore, but that's something we should take lightly. We always want to deliver the latest data from our database. At the same time, our app is mostly data-driven. If a user goes offline, they'll be able to see the site, but not the data. It'll mostly appear empty. We'll need to cache the data for when the user goes offline. There's another strategy we can use called network first, then cache. We'll always request the data over the network. The data returned by the network will be stored locally. We'll have a local copy of the data stored in the user's browser. If the user goes offline, we'll be able to use the data from the cache to make it seem like the app is still functional. We can even sync changes when the user comes online. The cache is only used for when the user is offline. We have two different strategies we'll want to implement if we want to provide a complete offline experience. These are not the only strategies available. If you were to search online, you'll find dozens of examples for different strategies. Luckily, by using Workbox, we can avoid most of the complexities of caching. However, it isn't always reliable. As we saw, it couldn't cache images. In the next lecture, let's try extending Workbox to include images in the caching process.